So today we're talking about motion from chapter 2. But before we can get into a more detailed discussion, we're going to first talk about square roots. So if I ask you the question, what's the square root of 25? You guys would quickly blurt out the answer is obviously 5. You can even plug it into a calculator and you get the same thing. But that's a little bit of an oversimplification. So let's look at a function. Let's say we have x squared is equal to 25. So you guys probably remember from algebra, it's x squared equals 25. We have to do the inverse operation of squaring, which is to take the square root of both sides. So now we have x equals 5. And we're done, right? Wrong. It is true that 5 squared is equal to 25. But it's also true that negative 5 squared is equal to 25. So x could be 5 or negative 5. So really it's x equals plus or minus 5. So back to our original question. Square root of 25, you could write it as plus or minus 5. Now in certain contexts, in fact I might argue in most contexts, it's okay to assume that we're only interested in the positive 5. But that's not the case in this class. So remember, when you're taking the square root in this class, we're going to assume that the answer could be either positive or negative, and that we're going to have to use context from the actual problem in order to figure out if it's positive or negative. So that being said, we're going to try to solve a problem now. So we've gone over displacement, velocity, and acceleration, basic equations for those three, and then we have 4 other equations that we're using, which concern displacement and final velocity. And then we have a variant of those same 4 equations where we set the acceleration from rest, so the initial velocity is 0. So now we're going to look at a problem and we're going to figure out which equation we're going to use. So Christian is pushing a stroller from rest accelerating at 0.5 meters per second squared. What is the velocity of the stroller after it has traveled 4.75 meters? So what is the velocity of the stroller after it's traveled 4.75 meters? Again, Christian started from rest at 0 velocity, accelerated at 0.5 meters per second squared. So our first step is to take note of what we have, what information we're given. So we're given initial velocity equals 0. We don't know the final velocity. We know the acceleration, 0.5 meters per second squared. And the question said, what is the velocity after 4.75 meters? So it looks like it's looking for a final velocity. So that's what we're not sure about, final velocity. That's what we're trying to find. So let's take a moment and look at some of our equations. These are the 4 equations that I mentioned. Delta x, so displacement, This is a displacement formula. This is a formula to find final velocity. Now we have another displacement formula, and then finally another final velocity equation. And these are just a variation of the same equation, assuming that velocity initial is 0. So it's like you plug in 0. For example, we plug in 0 here for initial velocity vi, and this equation becomes delta x equals 1/2 times vf times delta t, because vi is 0. And that's exactly what we have. Delta x equals 1/2 initial velocity times time interval. So let's look among these 4 equations, see which one we need. Well, actually, remember, Christian started from rest, or from an initial velocity of 0, so we can look on the right side. We use these equations for an object that starts from 0 velocity, accelerating from rest. So we were given initial velocity, acceleration. So those are the 2 things we're given: initial velocity, acceleration, and we're given after 4.75 meters, so we're given a displacement. So we need an equation that can take into account displacement, acceleration, and initial velocity, and give us the final velocity. Let's see what we got. So this one gives us displacement. We already have that. This one gives us final velocity, given acceleration and time. We don't actually know the time, so this is not useful. Here's another one for displacement. We don't really need displacement right now. Finally, this is one for final velocity. We have an acceleration, which we do have, and displacement, which we do have. So we're going to use this one. I'm going to write this down. Final velocity squared equals 2 times acceleration times displacement. So I'm going to write that. So I just copied down the formula. Final velocity squared equals 2 times acceleration times displacement, or delta x. So let's go ahead and solve this. Start plugging in some numbers. Final velocity squared is equal to 2 times acceleration, which was 0.5 meters per second. 0.5 meters per second times delta x, which is displacement, which we have as 4.75 meters. 4.75 meters. I'm going to grab a calculator. Two times 0.5 times 4.75 equals 4.75. So final velocity squared equals 4.75. But of course, we don't want to find final velocity squared. We're actually interested in the final velocity just by itself, not the squared addition. So, as we remember from algebra, we use an inverse operation. to get rid of this exponent to the second power. So we'll do a square root this, square root of this. Final velocity equals remember what I said. Don't fall for that trick. Before you start plugging into your calculator, remember it's plus or minus. Now, let's take the square root. Square root 4.75 equals, I'll round up to the second decimal, just say 2.18. Now in this case, the information was all given to us in the positive direction. It never said that there was a change of direction, so I'm going to assume that the stroller is continuing in the positive with a positive velocity. So I'm going to go ahead and say, based on the context of this problem, this is a positive 2.18. Final velocity equals 2.18 meters per second. So that's how we solve these types of problems. Start with the information that you're given, take note of it, look at what you're looking for, find the right formula that you need, then start plugging in numbers finally and solve the equation. So it's as simple as that. And admittedly, it's not always that simple. So we're just going to have to keep practicing this skill, and over time, we'll get better and get a lot more comfortable with it.